Hi, so for today's topic, we're going to talk about solving equations and checking your solution. So you should have already learned how to solve equations. So this isn't new, so I'll go a little bit quicker through the solving section. But then the newer thing that we're going to talk about is checking your solution. So how do you know whether your answer is correct? There is a way to tell. You don't have to just submit your answer and then hope for the best. There's a way to check your answer, to double check and make sure that what you're submitting is correct. Our essential question is, how do I check whether my solution is correct? And that's what we'll be answering in the coming moments. So we're going to start off with one-step equations. Start off simple, and then we'll work our way up to multi-step equations. So start off basic. We have 3x equals 12. We already know that 3x is multiplication. This is 3 times x. And we know we need to do inverse operations to solve. So instead of 3 times x, to get rid of this 3 and get x alone, we need to divide by the value that is next to x, the value that we want to get rid of, which is 3. So we're going to divide by 3. And remember, if we divide by 3 on the left, you can't, it's an equation, so whatever you do to one side, you got to do it to the other. So we also going to divide by 3 on the right. This becomes a giant 1. And we're left with x equals 12 divided by 3, 4. So now we know x is equal to 4. And now we need to practice, how do we check that that is correct? How do we know 4 is the correct answer? Simply put, take your original equation of 3x equals 12. And just like we did with evaluating expressions, you're just going to take that x and change it to whatever you think that is equal to. So we said it's 4. So instead of 3x, we're going to put 3 and 4 in our parentheses because we're substituting 4 back into our problem. 3 times 4 is 12. 12 equals 12. If they're both the same number, then our check shows that 4 is the correct answer. If you were to get 10 on one side and 12 on the other, then they are not the same. That means you have to go back to the drawing board and try the problem once more. We got 12 equals 12, so that is correct. So let's say we have x minus 7 equals 13. So I'm going to add 7 on both sides because remember, we always do the inverse operation. So instead of x minus 7, I'm going to do x plus 7. And then I'm going to add 7 on the other side. This makes a 0 pair. It's gone. So I'm left with x equals, and I'm going to say this is equal to 21. I'm going to say this is 21. And to see if this is correct, I'm going to go back to my original problem of x minus 7 equals 13. And let's see what I get. So instead, I'm going to substitute 21 back into my problem for x. So it'll become 21 minus 7 equals 13. And then I'm going to actually do that subtraction. What is 21 minus 7? That is 14. Let's see if it equals 13. 14 and 13 are not the same. These are not equal. So that means this 21 was incorrect, and I need to go back and resolve. 13 plus 7 is actually 20. 20 minus 7, that would have been 30. So then if I were to do 20 minus 7, that would have equaled 13. And that's correct. So my correct answer should have been 20. So this is what I mean by checking your solution being helpful, because if I were to substitute it back into the problem and notice, hey, that is not the right answer, then I need to go back to the drawing board and try that problem again. All right, now we're going to move on to multi-step equations. So we have 3x plus 2x minus 6 equals 4. We already know 3x and 2x are like terms, so I can combine 3x plus 2x to 5x minus 6 equals 4. And remember, you just drop everything else down that you haven't used yet. Now I want to get x alone. I noticed that there's only an x on the left side, so I want to move everything away from the left side. So I have this -6 here that I want to get rid of. To get rid of it, I'm going to add 6 on both sides. This made my 0 pair. I'm left with 5x equals 10. 4 plus 6 is 10. Now I still have this 5 on this x that I need to get rid of. And remember, this is multiplication. So 5 times x, to get rid of this 5, I need to divide. That's the inverse. Divide by 5 on both sides. 5 divided by 5 makes my giant 1. I'm left with x equals 2. So it's great that I found an answer, but now let's see, is that the correct answer? So instead, I'm going to rewrite my problem. So 3x plus 2x minus 6 equals 4. Instead of x, though, I'm going to substitute in the value 2 to see if I solve it, would I get the correct answer. So instead of 3 times x, it's going to be 3 times 2 plus 2 times 2, instead of 2x, minus 6 equals 4. And according to my order of operations, I multiply first. I'm going to get rid of all of my multiplication. 3 times 2 is 6, plus 2 times 2 is 4, minus 6 equals 4. 6 plus 4 is 10, minus 6 equals 4. 10 minus 6 is 4, and that does equal 4. So that is the correct solution. So now this is multiple steps. First, you get a value and you figure out what that x is equal to, but then to check it, you just substitute it back into the problem, just like we did for evaluating expressions. All right, we're going to try 2 more problems just to get some extra practice. So we have 2x minus 4 equals x plus 8. So remember, we want to leave the variable, the largest variable, on the side that it's on currently. So 2x is larger than x. So that means I want to leave my 2x alone and move everything else away. So I have 2x minus 4. I want to get rid of this minus 4. So remember, for subtraction, the inverse operation is addition. So I'm going to add 4 to get rid of it. That makes a 0 pair. Whatever you do to one side, you have to do to the other. So I'm going to add 4 on the other side. Since that made a 0 pair, I was just left with 2x equals x plus 8 plus 4 is 12. So now I want to leave this x, these 2x over here, but now I have another x on the right side. So I need to move it to the left side. And the way to do that is it's currently a positive x. So to get rid of it, I need to subtract an x. And remember, if I subtract an x, I also have to subtract an x on the left. X minus x makes a 0 pair. Now it's gone. 2x minus x is just x equals, and then you're left with 12. So that means to check my solution, I need to substitute 12 back into every section that I see in x. So it's currently the problem 2x minus 4 equals x plus 8. So instead of x, I'm going to now put 12 and see if when I evaluate, would I get the exact same thing. 12 minus 4 equals 12 plus 8. 2 times 12 is 24. Minus 4 equals 12 plus 8. Now we just have to add and subtract. 24 minus 4 is 20. 12 plus 8 is also 20. That was my correct solution. Last problem. Remember, when you have a fraction, this means division. And when you have division, that's typically what you want to try to get rid of first. Because you work the furthest away from x and you go backwards. So to get rid of this 5 and this divided by 5, you need to do the opposite, which is multiply by 5. And if you multiply by 5 on the left, you got to multiply by 5 on the right. So 5 divided by 5 cancel each other out. You're just left with 1. And then you're left with 6x in the numerator. And it's left alone because the 5 is gone. Equals 12 times 5 is 60. So now we're left with 6x equals 60. And we need to still get rid of our 6. And remember, this is multiplication, so the inverse would be to divide. So we're going to divide by 6 on both sides. Our giant 1 was made. X equals 60 divided by 6 is 10. And to check, we need to take our 10 and substitute it back into our problem. So our original problem was 6x over 5 equals 12. So instead of this x here, we're going to put 10. So it's going to be 6 times 10 divided by 5. Let's see if that equals 12. 6 times 10 is 60. We're dividing it by 5. 60 divided by 5 is 12, and that equals 12. So that is the correct solution. And the correct solution is 10. Don't get mixed up, which a lot of people do, is that they'll say, oh, 12 equals 12, so then x equals 12. Remember, that was the answer you were solving for, but the actual value of x is still 10. Just because you checked it and you got 12 equals 12 doesn't change the solution to be 12. The solution of 10 is just correct. So don't get those two mixed up. Just because you end up with a different check doesn't mean your solution changes. Your solution is still whatever you originally substituted back into the problem. So to conclude, in order to check your solution, first you have to solve the equation. You have to have a value to insert. If you don't have a value to insert, then there's nothing to check. So first solve the equation, then substitute that value back into the problem and solve and see if you get the same thing on both sides. If you are still confused by this, please feel free to ask your teacher. If you got it and you're on the roll, move on and we will see you for the next lesson. Bye.